Hi, in this example, we're going to discuss the linear model for barrels of oil. So suppose that the world's current oil reserve is 1,800 billion barrels. If on average the total reserves is decreasing by 24 billion barrels of oil each year, answer the following. Part A, give a linear equation for the total remaining oil reserves in terms of T and numbers of years since right now. So there's a couple of things that we want to note. The first thing we would want to note is the fact that the units are in billions of barrels. And so as long as we keep the units in billions of barrels, we'll be fine. So as long as everything is in billions a barrel, we're fine. So here, notice that it says the oil reserves are, we know that that will be billions of barrels. And then in terms T, which is in years. So the other part that we have to highlight is the fact that we have to give a linear equation. So we do know that the linear equation in general is y equals mx plus b. And so we always need a y, and in our case is r. The function notation would be t for the input variable, and we'll have mt plus b. So we're going to have to go ahead and find the slope and the b. Now recall that the slope itself is a rate, where the b is the initial amount or the starting amount, and graphically we know it as the y-intercept. So it looks like we knew that right now the oil reserves is 1,800 billion barrels. So in this case, currently, we have 1,800 billion barrels. Okay, and then the other part is it's decreasing by 24 billion barrels and then per year. And we wanted per year anyways because T is in years. Okay, so let's go ahead and set this up. So the first thing we need to do is kind of put for part A, y equals some sort of form of mx plus b. But we rewrote it over here as r of t equals mt plus b. Okay, and then we know a couple of other things. So let's highlight that currently we have 1,800 billion barrels. So this becomes R of t equals mt plus 1,800. And the other part, we have to be a little careful here, is that if it's decreasing, we know that that would be negative, right? Because we are subtracting. And the other part by 24 billion barrels per year. So in this case, the slope will be negative 24 t plus 1,800. Okay. So part B asks, well, if you have a function now from part A, what is the total number of barrels of reserves 8 years from now? So we ask, did they give us the number of barrels or the number of years? Because if they give us the number of barrels, we know that that is R. If they give us the number of years, then we know that it is T, right, for T years. And we can see that they gave us years, which is T. So for part B, we need to find R when t is equal to 8. So we're just going to essentially find r of 8 which equals negative 24 times 8 plus 1800. And we can easily just put this in our calculator here. And this is Desmos that I'm using. So negative 24 times 8 plus 1800 gives me 1608. And so in context of the problem, this means that after, so this is the answer. But in context of the problem, we would say after 8 years, there is 1,608 billion barrels of oil, which is a lot. It's beyond billions at that point, right? Okay, and then in part C states if no other oil is deposited into the reserves, when will the world's oil reserves be completely depleted? So we ask again, do they give us the number of billions of barrels? Well, yeah, it looks like they did. I could see that they didn't give us any years anywhere, and they also are asking when. So when it the word when itself tells me it's going to be a time will be the answer. And when the world's oil reserves depleted, does that mean is there any left? Right? No, right? There's none left. And that means that R is 0. There are no billions of barrels left. So for part C, we'll do C here. We need to find T when R is equal to 0. And essentially what we're looking for now is the x-intercept. So if R of t is equal to negative 24t plus 1800, then this is equal to negative 24t plus 1800, which is equal now to 0. So we're just going to go ahead and make sure those two match. And then solve for t as usual. So we would subtract 1800 and then divide by negative 24 to get t. And we can easily do this in the calculator, right? We could say negative 1800 divided by negative 24, 75. So this is the answer, but in terms of the problem, we can see that after 75 years, the oil reserve is depleted. Okay, I hope this helps.